Alright, so today we are going to talk about the laws of indices. Now, the first thing, all these laws, is the best way you can do is not by memorizing them, but by doing some question. So, let's get on to it. The first law states that a to the power of m times a to the power of n will equals to a to the power of m plus n. Now, one thing you must take note, a is the base, alright? So, just a pretty refresh. A to the power of m, this a is what we call as the base, alright, and m here is what we call as the power, alright. The base can be an alphabet, can be a number, the power can be an alphabet, can be a number, it doesn't matter. Now, the laws of indices only applies when your base is the same. So, for the first law, if you notice, both of my base are the same. So if my base is the same, I can plus the power. That's what the first law is telling you. Alright? So if there's times the power, I'm going to plus, but with the condition that my base is the same. Now let's go on to understanding the questions. Simplify each of the following. The first question, I have a 4 to the power of 5 times 4 to the power of 3. So again, I'm looking at my base. If my base is the same, both of them are 4. Hence, the power I can plus. So, what I'm going to do here is 4 to the power of 5 plus 3. And here my answer I'll get is 4 to the power of 8. That's it. Question asks me to simplify, not solve. So, simplify, this is how I simplify. Now, for B, again, they are all times. I can see all my base is the same. All are number 13s. Now, if let's say the number doesn't, the question did not mention any power, the invisible power is number 1. Alright, if there is no power, the question did not mention any power, the invisible power is number 1. So how am I going to solve this? Since all the base are the same, hence I know the base is 13, the power I can plus 6 plus 9 plus 1, hence here I will get 13 to the power of 16, and this is simplified. So remember, if your base is the same, the power you can plus if there is times in between them. Alright, you must have multiplication in between them. Now let's look at C. Now C, one thing you must notice, you must always identify the power is with what? In here, the power 7 is with the alphabet P, the power 4 is with the alphabet P. So what I'm going to do, the numbers here, I do not have any powers with them, and the numbers I can solve. So 2 and 5 here, I can just times them, alright? So 2 times 5, I'll get 10. And for the alphabet, I'm going to solve using the laws of indices. So P7 times, that means plus 4, alright? Because the base is the same, the power I can plus. So remember, since the numbers here, they do not carry any power, the power 4 and 7 is not for the numbers, it's for the alphabet. So the numbers I can just solve it by timesing it. So then when I try to solve this, I'll get 10. P 7 plus 4, I will get the answer to be as 11. So 10p power 11, this would be my answer. Now let's look at this. In here I have 2 different alphabets, alright. So first, if let's say you have 2 different alphabets, you solve the alphabet first, alright. You solve each alphabet individually. So X, you're going to solve with X, alright, and Y, you're going to solve with Y, okay. So try to separate them first. Here, X, even though the question did not put any power, the invisible power is 1. So for the first one, I know X power 1, and there's a times here, and here is X power 3. So times, I know I'm going to plus my powers. So here I'm going to do plus 3, alright. And then I have a Y here, Y. Here there is no power, so the invisible number is 1. So Y power 1 times, that means I'm going to plus here Y power 5. Alright. So this is how you solve algebraic indices. So here I will get X, 1 plus 3 is 4, and Y, 1 plus 5 is 6. This is how it's solved. Alright. So the difference between question C and D, question C, the numbers here, you can just times it. It doesn't matter. You can just times it and you can get your answer. Alright. So the power is with the alphabet. Hence, I'm going to use the laws of indices. because times, that means I have to plus, that's why I'm plussing the 2 powers here. But for question D, both of them are algebra. Alright, both of them are alphabets, x and y, they're all alphabets. You don't say any numbers here as the base. So x and x here, since they're both at the same base, alright, so what I'm going to do, I'm going to take the base, and here the invisible power is 1. There's a times in between, so that means I'm going to put a plus here. So 1 plus 3. And same goes with y, since both of them have the same base. So here the invisible power is 1, and there's a times. So I'm going to put y power 1 plus, and here is 5. And once you simplify it further, you should get that answer. Hope that is clear. Now let's go to the second rule. The second rule of indices is about division. Now if times we plus, for divide we are going to minus them. Alright, there's a mistake here. For divide, we are going to minus them. Alright, again the same rule apply. If your base is the same, the power you can minus. Simple as that. Now let's look at the question. So simplify each of the following. Here I have 12 power 11 divide with 12 power 5. Divide, I know I can minus the power. My base is the same, so I'm going to minus off the power. So here 12 power 11 minus 5. Alright, that's all I'm doing. 12 power 11 minus 5. And here 12, 11 minus 5, you would get the answer to be as 6. Alright, this is simplified already. Now, another way we can write division is using fraction, because this question, another way you can write it is 30 power 8 divide with 30 power 2. Alright. So usually, instead of writing division, some of the time the question they like to write it in a fraction form, but it is the same thing. Now, how am I going to do this? First, you have to look. 38 and 2. We know divide we have to minus. So 8 and 2, which means this 2 completely goes away. It completely cuts off. And 8 minus 2 here you are left with 6. That means there is still 6 on top. Now, how another way you can look into this? 30, there are 8 of them. So you can see 30 times 30 times 30 times 30 times 30 times 30. 1, 2, 3, 4, 5, 6, 7, and 8. Alright? And bottom, there are 2 30s. Okay, another way you can look at this is like this. So when you want to cut, if bottom you're cutting 1, on top you're cutting 1. Bottom you cut 1, on top you cut 1. And if you notice at the top, only left the 30, which is 6 of them, which is 1, 2, 3, 4, 5, 6. So this is another way you can look at it. Alright, but instead of doing this way, this is what we call repeated multiplication. So instead of doing this way, another way you can do is you can just cut off the powers. Alright, so once you cut off the powers, here the only thing that is left at the top is only left 30 power 6. Bottom, nothing left. The 2, you see, as you can see, my repeated multiplication is completely gone. Alright, so this is how we solve for division. You can just cut off the power. Since 8 is greater than 2, so 8 minus 2, there's still 6, which will be at the top, not at the bottom. Now, let's look at this. 48r power 21 divides 6r power 14. Now, whenever there's division in indices, I like to put them in fractions. It's easier. So, in here, I would just like to do 48r power 21 divide with 6r power 14. Alright, it's easier once you do it in fraction, you will get a hang of it. So first, what I recommend, when you have a number and the power, same like the multiplication, we will solve our numbers first. Alright, always solve your numbers first. So this one, you can put it in your calculator or you can simplify. So here when you simplify, you get 1 and this you get 8. And now for the alphabet, you are going to just cut it off. So 21, we know divide means minus. So 21 minus 14, you would get your answer to be a 7. That means at the top, there will be 7 remaining. And at the bottom, the whole thing is gone off. Because there's no longer R. All 14 R's are cut off. But at the top, there's still 7 R remaining. So here your final answer. At the top, what is remaining? Only 8r power 7. At the bottom is over 1. There's nothing remaining except the number 1. But usually we do not write over 1 here, so we can just write this as our final answer. Now for question D, they write in fractions. So all I'm going to do is I'm just going to try cutting it off. So a power 7 and a power 4. We know if 7 minus 4, 4 completely goes away and there's still 3 here. Alright. B power 8 and here there's no power. So we know the invisible power is 1. So 8 minus 1, the b power 1 completely goes away and 8 minus 1 you get 7 here. So as you can see at the bottom there is nothing remaining. So here the final answer, at the top there's only a power 3 and b power 7. At the bottom there is nothing remaining here. So that is what our final answer would be. Alright, so that is how we do the second rule of division. Okay, remember when you divide your powers you're going to minus. Now the third rule is on brackets, which we call as multiplication. Now a bracket also meaning multiply. So if let's say I have a power m bracket n, that means the power I'm going to times, I'm going to multiply them. So let's look at this question. Simplify each of the following. 6 power 7 bracket 4. So again, a bracket here means times. So in here, how am I going to solve it? 6 power 7 times 4. Alright. We know 7 times 4, it will become 28. So here your final answer will be 6 power 28. That's it. A bracket means times. Now in here, what I'm going to do, these two powers, since there's a bracket, I'm going to times them. Alright. So in here, p power 3 times 5. And here I would get p power 15. Simple as that. A bracket, alright, the power you're going to times. That's it. Now, if you go down, now at question C and question D is where most of the students, they tend to do mistake. Most of the time, the common mistakes that students do for question C is that they will just times this one. You know, this is a common mistake. Alright. So what they do is they will just do 3 power x 2 times 4 and then they will tell me it's 3 power x, 3x power 8. That's what they tell me, which is wrong. Now why is this wrong? It is because you see in the bracket x square is not the only item, is not the only component in the bracket. Alright. In these brackets there are two things. You have the number 3 and you have x2. So there are two things, which means this power 4, which is outside of the bracket, it is applied to also number 3 and to also x squared. So just pay attention to this. It's a very common mistake that students do. So which means this power 4, you're going to times with 3 and you're going to times with x squared. Alright. So how do you write this? So 3 is power 1, right? So 3 power 1. And when you times with 4, you can times 4. And here x square, bracket means times 4. So here you get 3 power 4 and x, here you will get is power 8. Now what is 3 power 4? You can solve it, alright? 3 power 4, you should get, the calculator will give you the answer as 81. And here you can get x power 8. So this is completely simplified. So just remember, in the bracket, that means both items inside the bracket, you have to multiply the power inside. Alright, this power 4, you have to multiply with 3, you have to multiply with x squared. Now for question D. Now this is also a common mistake that most students do. They will just multiply this power 2 with the top one. What about the bottom? The bottom, it is also included in the bracket, correct? So just remember the power 2 you have to multiply with 8 and also you have to multiply with the bottom. Alright, both up and down. So for question D, how can we simplify? M power 8 times 2 over n power 5 times 2. You see, the power 2 I'm multiplying with the top and also with the bottom. So here I would get m power 16 over n power 10, and this is simplified. So just pay attention, the outside power, alright, for if let's say there are 2 or 3 elements in the bracket, you have to times with each and every element. Okay, now the next part will be the fourth rule is a power 0. Now any number, alright, the fourth rule basically tells you that any number, I'm just going to put a note here, any number with power 0 will give you the answer 1. Alright, so you can put it in your calculator right now. You can do 7 power 0, you will get 1. You can do even 1,000 power 0, you can get 1. You can even do 9999999 power 0, and your calculator will give you 1. So from here we can know that any number power 0 gives you 1. Alright, now this is a very important rule that most students, they kind of neglect. So just keep this rule in mind. Now the fifth rule is when your power is a negative. Now this is where students, they tend to do a lot of mistakes. When your power is a negative power indicates that, hey, this particular alphabet or number is supposed to be at the bottom of a fraction. It is supposed to be as a denominator. Alright, so first thing, before you're dealing with negative powers, you must be very familiar with converting negative power into fractions and vice versa. For example, if I ask you, state each of the following in 1 over a power n. So this negative power, another way you can write it is also 1 over 5 power 3, which it can also, once you simplify it, it can be written as 1 over 125. Alright, so this is solved. Okay, so 0.7 power negative 6. Another way to write this, instead of having a negative power, another way to write this is 1 over 0.7 power 6. Alright, so this is just another way of writing it. And if you want to solve this, you can just solve this. You will get 1 over 0.117649 if let's say you're solving it. But if you don't want to solve it, you can put it like that. It's also okay. So you must be very familiar in converting a negative power and writing into a fraction. You must be very familiar in writing a negative power into a fraction and vice versa. You must also be familiar in writing a negative power back into fractions, or a fraction converting it into negative power. For example, you have to write it in negative. So 1 over 6 power 9, another way you can write it is 6 to the power of negative 9. 1 over r cubed, another way you can write it is r power negative 3. Alright, this is just another way of writing it. But one thing you must bear in mind, if you want to put the negative, you want to write a fraction into a negative power, you have to make sure that your top number is 1. Your numerator is always 1. Alright, you have to make sure of that. If your numerator is 1, the bottom, the denominator, you can bring the power up and you can write it as a negative power. Okay, now let's look at this. Express, for example, express 2 over 9 and the whole fraction is in the bracket, power negative 1 as a positive index. As a positive index, most probably question is asking me, hey, how can I convert this negative power into a positive? It's very easy. All you have to do, you just have to flip the fraction. Once you flip the fraction, alright, any negative power fraction, once you flip it, it becomes positive, and vice versa. So, for example, this one, you want to write it as positive index, you just flip it. It becomes 9 over 2 power 1. That's it. You just flip it. Alright? Now, x over y power 4. So, this is a positive power. And now they ask me, write it as a negative index. Very easy. A positive, you want me to change it to a negative. I'm just going to flip the fraction. So, here I'll get y over x power negative 4. That's it. Alright? So, this is the shortcut. If let's say a negative power, you want to change it to a positive, if it's a fraction, you just flip the fraction and it becomes a positive. If it's a positive power, you want to change it to a negative. You flip the fraction and it becomes a negative. Alright? Now, the sixth rule is when you have a power m over n. Now, m and n, they are numbers. Alright? M and n, they are numbers. So, how do we solve this? Now, another way we can write this is n root a power m. Alright? Now, remember at the bottom of our fraction here, at the bottom, it's always a root number. A root number. And at the top, or the numerator, this is what we call fractional indices. At the top of the numerator is always called the power number. Alright? So on fractional indices, the bottom is always the root, the top is always the power. So for example, state each of the following in the form of n root a. Alright? That means you have to write in this form. Okay? So 8, 1 over 3. Now 3 is always the root and 1 is always the power. So another way you can write this is 3 cube root of 8 basically, and 8 power 1. So usually power 1 we don't write, so that's not necessary. This is another way you can write it. 2, 5, 6, 1 over 8. 8 is always the root number. The root number. And 1 is always the power. So another way you can write this is 2, 5, 6, root 8. Alright, power 1, but usually power 1 we don't write. This is just another way of writing it. You must be very familiar in changing this into this and fractional indices back into the roots. Alright, so now write each of the following in the form of 1 over a power n. That means they're asking you, hey, convert this into fractions. So how do we do that? Now, this is a square root. So we know a square root usually here will be the invisible number is 2. Alright, power 2 usually in a square root we do not write. So another way we can write this is 1, 2, 1 power 1 over 2. Alright, because this 2 here, the 2 here as the denominator tells us it's a square root. Now the second one, root of 6, 7 to 9. So in here, another way we can write it is 7 to 9 power 1 over 6. Alright, so this is how we can write this number to this and fractional indices back to a root type of number. Now let's look at this. Now this is a very typical questions that comes out in exams. Without using a calculator, find the value of 32,705. Now, and they said without using a calculator. So what am I going to do? Now, when you look at a fraction, when you have a fractional indices, the first thing that you must be concerned about is how you can get rid of your denominator. Alright, step 1 is get rid of your denominator. As simple as that. Okay. So in order for you to get rid of the denominator, you must look at the base number. You must think of a number. What number, power 5, I will get 32. Alright. So basically what you must think is, what number, power 5, alright, and you will get 32. Just 32. What number, power 5, you will get 32. So if you try to play around with your calculator, you will know that 2 power 5, you will get 32. Alright. So in here, I know that 2 power 5, I get 32. And 705 is just at the outside there. Now this is times. Now if let's say I just magnify this, alright, this is 5 times 7 over 5, alright. So we know when we times, there is something that we can just cancel out this and we'll just get 7 as our answer, correct? So for here, for this part, what you can do is you can literally just cut off this 5 and this 5, alright. So once you cut off this 5 and this 5, the only thing that you're left now is 2. Here will just be 1 and 7 at the outside. So we know for bracket, the power will be times. So 7 times 1, we'll get 7. So this is 2 power 7. And the answer for 2 power 7 you will get is 128. That's it. Alright, so remember, in order for you to solve a fractional indices, your main goal is you must get rid of a denominator. And how do you do that? You look at the base number. Alright, you must think of what number that must be to the same power as the denominator here, that you will get back the base number. Now let's look at example B here. So I have 625 power 3 over 4. I need to solve this. Again, now what I'm going to think is, I need to get rid of my denominator 4. Alright, I need to get rid of this. So I must think what number that power 4, alright, then I put my denominator here 304, alright. So what number power 4, I will get 625. So since this number ends with 5, I know most probably the base will be 5. So I know that 5 power 4, I would get 625. So here I know that 5 power 4, I will get 625. Now why I need it to be power 4? Because I need to cut off with my denominator fraction here. I need to cut off the number with my denominator fraction. That's why I need to find a number that must be power 4. Here why I choose power 5? Because I need to cut off with my denominator fraction here. So once I do that, I can cut this off, and finally I will get here 5 power 1, alright, because 4 when you cut off it becomes 1 and 1 here. So 5 power 1, and outside I just left it power 3, and bracket, that means I'm going to times my power, so 5, 1 times 3 is 3, alright. So here my final answer 5 power 3, I will get 125, and that's it. It is solved, alright. So just remember, whenever you want to solve fractional indices, the first thing you must think is how can you get rid of the denominator. So you must always think of a number that could be the same power as your denominator, so that later on you can cancel out, like what I did here. Okay, you can pause and rewind back to see again how the way I do it, but that's how we solve it. So this is in a nutshell on all the laws, alright. So total there are about 6 laws. So if you can just practice on single questions on the laws, that would be helpful. Now let's try to go on some of the most complicated questions. For example, simplify each of the following. I have 3 power 5 times 3 power 8 divide 3 power 7. Now you see this is a combination of 2 laws. Here I have the multiplication law and here I have the division law. So what am I going to do? First, whenever you're doing indices, you always have to make sure that your base is the same. In here, all my base is the same. It's 3. Hence, you can use the laws of indices. So what I'm going to do, 3, I have 5 times, that means it's plus with what? 8. And then I have divide, that means minus with what? 7. So here, I would get 3, 5 plus 8. So I get 5 plus 8 minus 7, I would get 6. Alright? And here when I solve it further, but since this question just asked me to simplify, I will not solve it further. Alright, so I can just keep this as my power. Now for the B part, I have quite a number of things going on here, but the first thing I'll try to solve is always my bracket. Alright, let me just get rid of this. It looks quite messy here. So I know that this one, a bracket, means the powers I'm going to times. So that's what I'm going to do first. Alright, so I will take 7 power 4 times 7 power 6 times 2, I get 12 over bottom is 7 power 3 times 7 power 6. Now once I'm done with this, I'm going to play with my laws of indices. I know when times, that means the power I'm going to plus. So 7 power 4 plus 12, alright, over bottom here would be 7 power 3 plus 6. Alright, I'm just going to simplify as much as I can. So once I do this, I would get 7, 4 plus 12, I get 16, over 7 power 3 plus 6, I get 9. Alright, now you see I've already simplified as much as I can. the top and the bottom, the numerator and denominator, as a single number. So what I'm going to do now, I can use the rule of division. I can still simplify further because I can use the rule of division here. So in division, I know the power I'm going to minus. So since both of my base are the same, I can minus off the power. This is 7 power 16 and 7 power 9. I know 16 minus 9, I would get 7, which means this power 9 completely goes away. And this I would get remainder is 7. So here my answer is 7 power 7. And that is already simplified. Alright, did I do my calculation correct? Yeah, it should be right. Yes, should be right. So here I get 7 power 7. Alright, and if you want to solve it further, 7 power 7, you get 823,543. But for this question, since question just asked me to simplify, so there's no need for you to solve it. Simplify is just simplifying. If question asks me to solve it, then you have to give me what is the value of this. Now let's go to the next question. Find the value of each of the following. Now this is getting more complicated, so let's try solving the A part first. Now for this, at the moment, I cannot use the laws of indices. The main reason it is because here I have base 6, here I have base 6, but here my base is 36. Remember, laws of indices you can only use once your base is the same. So first, I'm just trying to simplify it, and I'm just trying to make my base the same. So instead of writing in a square root form, I rather write this in let's say 6. This is a power, alright, this 5 is a power. So I know it becomes 5 power, and this is a square root, so 5 power 2. Divide 36, I know there is a connection with 6. I know 6 square, I will get 36. Because at the end of the day, I'm trying to simplify it further, and I'm trying to make my base the same. I know 6 square, I get 36, so that is this, times, and this is already in the simplest form, 6 power 7 over 2. Now what I'm trying to do is, since all my base is the same, hence, and they are basically in the simplest form, it's easier to do it like that compared to doing in a square root, you know, something like this. So now what I'm going to do is I'm just going to try solving it. Since all my base is the same, I'm going to do 6 power 5 over 2, divide, that means minus, here's divide, that means minus, minus 2, times, that means plus 7 over 2. Alright, that's it. So this whole thing, once you write it in your calculator, so 5 over 2 minus 2 plus 7 over 2, you do it, you will get in your calculator 6 power 4. And that's it. And question asked me to find the value. Find the value, that means this is no longer simplifying. I need to know what is the value of 6 power 4. So once you do this 6 power 4, you will get 1296. So now, that is how I solve question A. Remember, you cannot use the laws of indices if, let's say, your base is not the same. Now, let's look at question B. For question B, I have, this is like in a bracket, this is like in a bracket, and there's a divide in between. And for question B, it's important for you to use the BODMAS rule, alright? Okay, in BODMAS rule, we try to solve as much as we can in the bracket, and then only we do times or divide, and then only we do plus and minus. But if I see that I cannot solve anything in the bracket right now, alright? Because for this bracket, 4 and 5, there's no any connection. I can't solve it, and neither can 2 and 5. So what I'm going to do is, first of all, I'm going to write it in, maybe I can try to solve this, you see. There's this bracket here, and then there's this power 2. Let me try to times this power 2 inside of here. Okay, let me try doing that to simplify the equation as simpler form, as the most simplest form. So here I would get 4, 9 over 2 times 5 power 4, there's a bracket, and then divide. So this 2 once a times in, 5 times 2, I will get 2 power 10 times 5, 3 over 2 times 2, I will get 5 power 3. Alright, you can do this in your calculator. You can do 3 over 2 times 2, you will get 3. Alright, so here will come 5 power 3. So now it's much more simpler. I don't have anything here. What I'm going to do is, maybe since it's a divide here and there's a times in the bracket, I can just write them in a fraction. Alright, but before I write them in a fraction, since there's no any connection, I know that this 5 is same base with here, but this 2 and this 4, they are not the same yet. Alright, this 5 has connection with this, but this 2 and this 4, they don't have any connection. So what I'm going to do is, I know that number 4 can be converted to base 2. Alright, so for number 4, I know that 2 power 2, I get 4. Alright, try your best to make their base same. So 2 power 2, I get 4, and this is 9 over 2 times 5 power 4. Alright, and this is divide with 2 power 10 times 5 power 3. So here I can just simplify this, and I would get now 2 power 9 times 5 power 4 divide with 2 power 10 times 5 power 3. Yeah, now it looks much more better. Now I'll be able to solve this because I see this number, I have connection with this, is the same base as this, and this number is the same base as this. Alright, so I can solve them. Okay, now how am I going to solve them? Like I've already put, so first I'll solve that 2. Maybe I can just put them in a fraction so that you can see it better. So what I'm going to do, divide, another way I can write it, it's in a fraction. So 2 power 9 times 5 power 4 divide with 2 power 10 times 5 power 3. Yeah, you can just write them in fraction and then you can just cut it off. Alright. So since it's the same, because laws of indices only apply in the same base, so you can solve this and then you can solve this. Alright. You can solve, let me put another color, let's see, green. Okay. So you can solve this and this separately. Okay. So 2 and 9, I know that 10 is bigger than 9. So 10 minus 9, that means 9 completely goes away. And 10 minus 9, I have remainder here is 1. Now 4 and 3, I know 4 minus 3, 3 completely goes away. And 4 minus 3 here, I'll get remainder 1. So what is left at the top? So when I'm writing this, what is left at the top? The 2 is nothing. On top is just left 5 power 1 over. At the bottom, only left 2 power 1. So since both number are power 1, you don't need to write the power. You can just basically get rid of the power here. Alright, you don't need to write this. So that would be your final answer. So this is pretty complicated. If you want, you can rewind back a bit. So in a nutshell, what I tried to do is, first I simplified this bracket. I use the law, or I can just times in the power outside to make my life more easier. The question becomes more simpler. And then I'm trying to compare. Alright, this 5 and this 5, I can solve it because they're in the same base. But 2 and 4, they're not really in the same base. But I know 4 has connection with number 2. Alright, I know that 2 power 2, I can get 4. So I try to make them in the same base. Simplify it further. And then since it's a divide here, I try to write them in a fraction and I solve them singly. And this is how I get 5 over 2. Alright. Now, the next question, let's say I have this. Now, simplify each of the following. 54y cubed over 6y times, oh, this is pretty complicated here. Now, the only thing I see, the most complicated thing that I see is this one here. This one, it's very complicated. So let me just try to simplify this as much as possible. First, let me try to simplify the bracket here. Alright, I mean, the moment you look at any indices question, you must think that what is the most complicated thing for you? Like for me, it's always like either the cube roots or anything that has roots in it. It will be definitely more complicated. So I'll try to tackle that first. So here I get 54y cubed over 6y times, And here, maybe I can write it as y. Since this is a root, this 3 is a root here and 2 is a power. So I'll write 2 over 3 and 6 is outside. Yeah, this looks more simpler. Alright, so this looks more simpler. Now I'm just trying to simplify it more. The 6 at outside, the outside 6 here, I can just times it, alright, with this. Okay, so this thing I can just break by timesing them. So in here, I will get 54 y cubed over 6y times, here when I do it, I would get y power 4. Alright, that's what I get, y power 4. Now you see it's becoming much more easier compared to the first one, compared to this one. Alright, so complicated. Now you see it looks much more simpler. That is your goal when you're solving indices. Whatever that you find the most complicated one, try to solve it so that you get in the most simplest form. So once I'm doing this, what I like to do is I'm looking at the fraction and I'm looking at the top there's only one term, but at the bottom you see I can simplify this further. Instead of putting 2 separate terms, I can make them into one. Alright, so that's what I'm going to do. I'm going to solve this. Instead of 2 separate, I'm making them into one. Alright, so once I do this, I would get 54y cubed over, so this is 6 times, in front of y the invisible number is 1, so 6 times 1 I get 6. Here is y power 1 times power 4, so I know times the power I can plus, so 1 plus 4 I'll get y power 5. And now you see it's really in the most simplest form. So what I'm going to do now is I'm just going to simplify. Alright, so this is 1, this becomes 9, I can just simplify the number. This is y power 3 and y power 5. Obviously y power 3 completely goes away, so 5 minus 3 I still have remaining 2 at the bottom here. So hence my final answer for this, at the top what is remaining? At the top only 9, over at the bottom it is only y squared. So that would be my final answer. So this is how you solve a complicated indices question. Alright, so when you look at the question, try to see which is the most complicated part and then you go from there. Now let's look at this. This is fairly easy. So first what I'm going to do is I'm just trying to break this outside power here. Alright, you can just times in inside here. Just times in here. Alright, so once you do that, you should get m, 9 times 2 you get 18, and n here you would get 12 over m, bottom is power 7 and n here is power 10. So you see what you can do now? You can solve this first and then you can solve this. Alright, you can solve both of them separately. Okay, so now when you're solving them, m power 18 and m 7 completely goes away, and 18 minus 7 here you have remainder is 11. And the next one, n12 and n10 completely goes away, and 12 minus 10 here you would get 2. So what is remaining at the bottom or at the denominator? There's nothing remaining. At the top you only have m power 11 and n power 2. And nothing is remaining at the bottom, so this would be your final answer. Now the last example I have on indices would be this. Now most of the time students confuse on how to do questions like this. Alright, now why are they confused? Because before you're doing this, you must know one rule. Alright, and I'll just write it down here. If you want to find your missing power, that means if let's say your power is the unknown, then you have to make your base the same. Alright, And same rules applies for vice versa. If you want to find your missing base, alright, then you have to make your power same. Alright, now what does it mean by this? I'll just put a quick example here before we solve this question. For example, if you want to find your missing power, let's say I have 2 power x equals to 8. Alright, 2 power x equals to 8. And I said, hey, find the value of x. So how will you find the value of x? First of all, you cannot find x because both of their base is different. This is base 2, this is base 8. In order for you to find your missing power, you have to make your base the same. You have to make your base the same. So we know 2 is already a prime number. There's no any, you can't go smaller than 2. But we know 8 have connection with number 2. So 8 you can make into base 2. So in here, how am I going to solve it? I know 2 power x is also equivalent to, how can I get 8 into base 2? I know that 2 power 3 gets me 8. I know that 2 power 3 gets me 8. So now, if your base is the same, you can compare the power. So if your base is the same, which means your power should also be the same. Hence, the value of x is 3. Alright? Remember, if you want to find your missing power, then you have to make your base same. So this is what it meant. Alright? If let's say the power is missing, you have to make your base same. So let's look at another question. For example, if I have 1 over 3 power x equals to, for example, let's put 27 here. Alright, something like this. And their question asked me find the value of x. Again, in order for me to find the value of x, since x is a power, I have to make sure my base is the same. But there are 2 problems here. First of all, this is written in a fraction, and this is just a whole number. But this fraction, if you're very good in your laws of indices, you know that there's another way you can write this fraction. Now, another way I can write this is 3. I can bring this whole thing power up. So 3 power negative x equals to 27. Correct? Because another way for me to write this is also like this. Clear? So now you can play with your base. So I know that number 27 have connection with 3. So I know 3 power negative x will be 3 power 3. So 3 power 3, I already know it's 27. So since my base is the same, hence I can compare the power. Alright? So which means negative x equals to 3. Hence, x will equals to negative 3. So this is the value of x. Alright? So this is how we can use the indices rules to solve. Just remember, to find your missing power, you have to make your base the same. And same goes with to find your missing base, then you have to make the power same. For example, if I have x power 3 equals to, let's say 27, alright, x power 3 equals to 27, and I ask you to find x. Now again, I'm finding a base. So in order for me to find the base, I need to make power same. So this 27 is power 1. It's not power 3, so it's power 1. So how do I make to make it power 3? I must think of a number. What number power 3 I get 27? So I know that 3 power 3 gives me 27. Alright? And here is definitely x power 3. So now you see, my power is the same. Hence, I can compare my base. My base should also be the same. So hence, my value of x is 3. So if you want to find your missing base, then you have to make your power same. That is the rule here. Alright? So, in light of these rules, let's try to solve this question. So given that 8x minus 8 power x minus 1 equals to 32, find the value of x. Again, they asked me to find the value of x. And x is basically a missing power. Again, if I want to find the missing power, I have to make my base same. So let me think. 32 and 8. Is there any connection between 32 and 8 here? So this is a slightly complicated question. There is no any connection here. But I know 8 and 32 have connection with one number. And that is number 2. So maybe I can make both of them as base 2. Because you see, at the end of the day, I want to find my missing power here. Alright? In order for me to find the missing power, which is the value of x, I need to make my base same. I know 32, there's no way I can make it as base 8. Alright? So I'm thinking out of the box now. I need to think what is the number that has connection with both number 8 and number 32. So the number that I'm thinking right now is number 2. Alright? I know 2 power 3, I get 8. Correct? 2 power 3, I get 8. So 2 power 3, and then here I have x minus 1. One thing I highly recommend, whenever you want to change your base number, always write it in a bracket. Please write them in a bracket. Alright? Just write them in a bracket. Equals to, alright, equals to 32. I know that 2 power 5, I get 32. 2 power 5, I get 32. Now, what I'm going to do is, maybe I can just try to simplify this part. Alright, I can just try to simplify this part. So this 3, I'm just going to times in here. So I'll get 2 power 3x minus 3. Alright, I'm just breaking the brackets. Alright, I'm just timesing this 3 out. Equals to 2 power 5. Now you see, what I've done is I've made my base same. So if my base is the same, I can literally compare the powers. Alright, I can literally write an equation for the powers. So here I will get 3x minus 3 equals to 5. Alright, I'm just now playing with the powers. So here I'm just going to use simple algebra to solve it. 3x equals to 8. So x equals to 8 over 3. Alright, and that is how you solve it. Remember, whenever you want to find the missing power, you have to make the base same. But at times, you got to think out of the box. Like for this question, both of these two numbers, they don't have connection with each other, but they have connection with another number, which is number 2. So I try to make both of them under base 2. Alright? And that is how we solve indices.